I have some legitimate concerns about this whole scenario business and future projections out to 2100, but that doesn't mean that I'm dissing or dismissing the work, RCPs, SSPs, and the ones before that we discussed. So I wanted to add few podcasts on this part to look at achievements and needs for the climate change scenario framework. So this came out actually before the release of AR6, and also proposes some future steps to improve the scenario framework, which also was mentioned in the SSP paper we looked at. So you have to decide for yourself whether these are worthy of the efforts of simulating so many future scenarios with all those uncertainties, and whether they are really useful and are being used. Governments demand them, but if you look at the talk, decision, and action, you cannot necessarily find the link. So is the climate community obliged to keep doing this because governments demand them? Keeping that in mind, let's look at some achievements. Of course, hundreds and hundreds, maybe thousands of simulations have been done with combinations of RCPs, SSPs, and so on. So obviously they are important. So let's do this and make a few points about what could be done to improve the scenarios if we really need to continue with these. Reading the abstract, long-term global scenarios have underpinned research and assessment of global environmental change for 4 decades, keeping in mind that the CO2 keeps increasing and has not shown any slowing down, in fact is accelerating. Over the past 10 years, the climate change research community has developed a scenario framework combining alternative futures of climate and society to facilitate integrated research and consistent assessment to inform policy. Okay, how exactly policy gets done is criticized by a lot of social scientists, policy experts, in terms of whether scenario simulations are meeting the needs and are actually useful for policy making. But we'll leave that aside. Here we assess how well this framework is working and what challenges it faces. We synthesize insights from scenario-based literature, community discussions, and recent experience in assessments, concluding that the framework has been widely adopted across research communities and is largely meeting immediate needs. Okay, so what are the immediate needs? We'll see some of these. However, some mixed success and a changing policy and research landscape present key challenges, and we recommend several new directions for the development, use of this framework. Okay, so what the framework's primary goals were and continue to be: to support climate change related research globally across research communities and be extendable to other scales, sectors, and issue areas; to facilitate research that integrates climate and societal futures by providing more detailed socioeconomic and political conditions as inputs to studies of impacts, adaptation, and mitigation. We've already criticized various aspects of these, so we'll just go through these as they are presented. To foster consideration of uncertainty in future climate and societal conditions by describing a wide range of plausible futures. This is the main goal, where you're providing what if scenarios for the future with lots of technologies that are still not there being a big part of reaching the goals or staying on the pathways that we have discussed under RCPs and SSPs. Keeping all that in mind, one should remember that these are not policy prescriptive, and they don't have all the scales to go down to local levels where often policies need to be made. Okay, to encourage more coherent synthesis in scientific assessments by improving the consistency of climate and societal assumptions in the literature, so that you have RCPs and SSPs which have to be combined with simulations to provide coherent pathways. And as we said, not necessarily internally consistent, but this is still the best we are doing so far. To support research and analysis to inform policy. So this idea of informing policy keeps coming up, and some people question the idea that there are some policy makers. This community is very not well defined. Policy makers, it's politicians, it's bureaucrats, it's people pushing certain agendas, elections, deciding certain issues, and so on. So keep all that in mind. Looking here, I will read a lot of stuff here because it's a nice paper and these words are important, and they are repetitive of some of the ideas we have already discussed under RCP and SSP, but it doesn't hurt to hear them again. The SSP RCP scenario framework. The SSPs and RCPs describe alternative visions of how society and climate may evolve over the coming decades, providing a framework for combining these pathways in integrated studies, as we'll see in a figure in a minute, and there's a reference associated with that. The SSPs include societal factors such as demographics, human development, for example health and education, economic growth, inequality, governance, technological change, and policy orientations. Most factors are given as narratives that sketch broad patterns of change globally and for large world regions. So you have to keep the scales in mind. A subset, so population, GDP, urbanization, and educational attainment are provided as quantitative country-specific projections. So the uncertainties change as you change the scale, so you have to be aware. These variables were chosen based on their common use as inputs to emissions or impact models and their relationships to each other. Again, there are some knobs to be turned with the integrated assessment models, like the damage function, for example. Discount rate is always a big player. Education, for example, was used in projecting both population and GDP. Population projections are always tricky, and GDPs, of course, depend on various factors like the pandemic or the Russian invasion of Ukraine, which I mentioned a lot of times. These basic SSPs provide core information to promote consistency across scenario-based studies, while extension to finer scales and sectors were encouraged to expand the utility of the framework to a wider range of applications. We've already discussed whether IAMs are really capable of doing this, or where the models stretched beyond their abilities to get this done because of a demand from politicians. 5 SSPs were developed to span a range of outcomes for 2 characteristics of society that we already discussed: the challenges that the underlying factors in each pathway present to adapting to climate change, and the challenges they present to mitigating climate change. The SSPs do not include mitigation and adaptation responses themselves, nor do they include the impacts of climate change. This design choice was made so that integrated studies can assess the effects of policies or magnitude of impacts included in their own studies by comparing outcomes to those in SSPs. So there's a lot of validation and evaluation done, at least for consistency. This approach allows SSPs to be used as a reference case for a large number of studies investigating a variety of policies and projected risks. Okay. Further, motivated by the fact that a wide variety of approaches to mitigation or adaptation policy are possible, SPAs were developed that describe a smaller number of broad approaches to these policies, along with other policy assumptions like radiative forcing or global warming targets. Scenario policy assessments are intended to foster common approaches across studies and support more robust assessment of mitigation and adaptation. Give me a second here, I have to pause. Sorry about that, I had to take care of something. So sorry, I should make sure I say things correctly. So we know RCPs are representative concentration pathways, SSPs are shared socioeconomic pathways, and SPAs are shared policy assumptions. Okay, societal conditions and policy assumptions are made, which are to be dealt with very carefully here. shared climate policy assumptions. Okay, so often they include societal conditions as well. Okay, so where was I? Along with other policy assumptions like radiative, motivated by the fact that a wide variety of approaches to mitigation and adaptation policy are possible, shared policy assumptions were developed that described a smaller number of broad approaches to these policies. Along with other policy assumptions like radiative forcing or global warming targets, SPAs are intended to foster common approaches across studies and support more robust assessment of mitigation and adaptation literature. So you are taking published literatures and then you are synthesizing them and making them consistent in this sense. Okay, so this is additional information that we didn't discuss in the under RCP SSP evolution podcasts. Quantitative projections of energy use, emissions, and land use based on the SSPs and SPAs were produced using integrated assessment models. SSP-based emission scenarios that do not include mitigation policy result in greenhouse gas concentrations by 2100 that are at the high end of the ranges covered by the RCPs. So RCPs had 2.6, 4.5, 6, and 8.5. So those were the radiative forcings corresponding to some concentrations, some emission pathways, and then you have SSPs. So you have to worry about these consistencies. However, each SSP can be made consistent with the lower levels of radiative forcing by adding assumptions about mitigation policy. Here is where the tricky part comes in terms of what we are relying on for staying on those pathways and what the policies include, like bioenergy and carbon capture, for example. The mitigation necessary to achieve a given forcing outcome in each SSP will differ according to its challenges to mitigation. So you remember we had challenges to adaptation and mitigation, and we had sustainability, regional conflicts, and fossil fuel based development, and so on. A selection of SSP based IAM scenarios were used to drive Earth system models to project future climate change. This new generation of climate projections is beginning to become available, so this was before AR6 was published. However, integration of climate and societal futures did not need to wait for these SSP-based climate projections. So AR5 was done with RCPs. Hundreds of studies have already combined societal futures depicted in the SSPs with climate projections based on the RCPs. The RCPs are pathways of greenhouse gas concentrations over time that were based on emission scenario that predated the SSPs, we know that, and a first generation of climate model simulations already produced climate outcomes projected to result from the RCPs. Using the SSPs and RCPs together is not inconsistent because it's been well established that many different societal pathways can produce approximately the same radiative forcing and climate change outcomes. Well, approximately. So how much warming does that result in? How the risks change? Are the models able to differentiate? Let's say we have a 2-degree target, 2 degrees C above pre-industrial warming and a 1.5 degrees C above pre-industrial warming. Are the models capable of telling the difference between half a degree in terms of risks? Maybe they are better at saying what happens with exposure to heat waves, but is that the same accuracy you get for increased extremes in rainfall or droughts? That's a tricky thing. Okay, we have to I keep commenting on uncertainties because we cannot really ignore them. Okay, so the SSP-based climate projections will serve to update and extend the original RCPs. That's what the framework is meant to accomplish. So looking at the scenario framework and process for producing integrated studies combining future climate outcomes, societal conditions, and policy assumptions, a more detailed version of this figure separating the successive generations of concentration pathways, climate model simulations, and integrated studies is available in the supplementary information of this paper, which you can look up, but I'm obviously going to be brief here. So here we are in the center, integrated scenarios and analysis, and they are being fed through policy assumptions, so SPAs impact the integrations. Societal pathways obviously affect them. Societal pathways also go into IAM scenarios of emissions, land use, and concentrations, which we discussed before, and they feed into the integrated scenarios and analysis. Climate simulations get IAM scenarios, emissions, land use, and concentrations, and they feed to integrated scenarios and analysis. And of course, we had the previously developed RCPs feeding into climate simulations. So we are coming into climate simulations from both sides and feeding in here. That's not inconsistent in only an approximate sense, because the resulting radiative forcings from RCPs and SSPs, or a combination thereof, can be slightly different, but slightly has to be used very carefully, because we are really talking about impacts of each watt per meter squared, or even each 0.1 watt per meter squared, that can produce local effects that are obviously related to things like polar amplification, or global south getting more extremes, Middle East and the Mediterranean warming faster, and so on. Okay, so we have to be careful.